You might. So we good? All right. Good morning. Good April 1st. It gives me great pleasure to introduce. I'm the guest MC today, so it gives me great pleasure to introduce Michael Witbrock. He was born in New Zealand, I think, and then came to CMU. Worked there, worked at Just Research, worked at Lycos, doing both knowledge-based and statistical methods. And then he went to this place called Cycorp, where he's been doing very interesting things. So I actually met Michael a little more than 2 years ago when he wanted me to come to Cycorp, and he almost succeeded. So that's Michael's accomplishment, or much to his credit. Every time I talk to him, there's been something very interesting that I walked away with. So I really look forward to the talk. And Michael Witbrock.
So hopefully I can show some of you that at least thinking about wanting to go to Cycorp is something that isn't completely ridiculous in your futures as well. So I'm going to talk a little bit about what Cycorp is. I'm going to try and speed through that because half of you already know this and are bored to tears with it, and half of you probably don't care. Then I'll talk a little bit about research, knowledge acquisition, insight, and then I'll talk a little bit about research, data willing we'll be starting to do in the next few months on acquisition of the means to acquire knowledge, insight. So that sort of motivation of the SITE project is to give computers common sense. It was sort of in the 1970s we were building lots of, in 1980s we were building lots of expert systems, but they didn't really know what they were doing. They could perform simple tasks, and if you went outside their domains they couldn't work at all. The idea behind Cycorp is that you can give systems the background knowledge required to generalize, to expand beyond what they were originally intended to do. And more than that, that if you give enough of this background knowledge, it can be used as a basis for learning in systems. It can be used as an inductive bias. So the SITE project's been around for 21 years now, starting in MCC, and it's been sustained over that time by, well, a mixture of paranoia about what Japan might do and sort of hope for the future. At the moment, since 1994, it's been an independent company, supported at the moment probably 80% by government grants. So in that sense, it's not entirely, in many senses, in fact, it's not entirely unlike ISI, apart from that the view is not nearly as good. So if I'm not looking at you, there's a good explanation. Right. So people have been at this for 21 years, and not all of that time was wasted. SITE contains an awful lot of information. It contains sort of very general knowledge about the world, about time, space, and so on. It contains more medium knowledge about sort of human activities, what it is to be an agent, what it is that humans are sorts of agents, very particular things about travel, including things like the existence of frequent flyer programs and the like. So it does reasoning generally by deduction. We also use induction and abduction in the system. We use induction offline and abduction during inference. And we can access other types of reasoning, such as fluid dynamics simulation during inference by a general mechanism called HR modules. It has a growing ability to support knowledge acquisition and use via natural language, and I'll talk extensively about that. Well, it's a general purpose platform, so we view it as a general purpose platform. We want people to use it as such. It supports a variety of applications. It's also a research platform. There's a version of it called OpenSite, which you can just download and use for whatever you damn well pleased that OpenPsych actually contains the basic taxonomic definitions and sort of wordnet relationships for every useful concept we've been able to identify in the knowledge base. We hope that you'll think at least about using that as the semantic vocabulary for your knowledge-based systems, and that's completely unencumbered. Research Psych is basically all in sight. You can use that for research purposes only. It contains not just the text relationships and the terms, but all of the rules and other sorts of relationships, of which there are about 15,000. I believe that ISI has already signed a corporate license for Research Site. So if you can track down who signed that license, anybody here ought to be. So all of you ought to be able to use Site in your research if you wish, and hopefully you'll wish. So what does Site contain? Well, about 15,000 relationships, about 280,000 concepts, such things as buying, sulfur, authoring, giving a talk, and about 2.5 million assertions. Although I recently saw a claim that that's like 3.3 million. So either people are counting in different ways, or we've added a lot of knowledge recently. We have been adding knowledge autonomously recently, but I don't think enough to account for that. And these rules are things such as, causes precede effects. Everything which is a cause, everything which causes something else starts, the thing that it causes starts after the end of after the start of the thing that causes it, rather. And drilling down, we have detailed representations of things pertaining to human beings, in particular things like conceptual works. There's quite a lot of sort of philosophical work done in that area to break apart, for example, this object is an information-bearing thing. The information represented it is a conceptual work. The particular piece of information which is represented on this particular piece of paper, and the underlying knowledge which is represented in each of the items on this piece of paper. So all throughout, that's the sort of thing that the philosophers have been employed at for the last 21 years. And I think they've done a reasonable job, a good enough job that we can start doing AI with the system and start doing knowledge acquisition with it. So Psych is not just the knowledge base and inference engine, although that's a big part of it. As I said, we have a large number of user interfaces for interacting with end users in various ways between domain experts and sort of completely untrained people. We have somewhat different interfaces for knowledge acquisition, for interacting with people, ranging from people who work at Cycorp who get this rather complicated interface to use, to simpler ones to be used by subject matter experts. We have a general interface to external data sources, where Psych can, for example, in the course of inference, plan and execute SQL queries across multiple SQL databases and use them online during inference. And we have an API which allows you folks to talk to Psych and use it in applications, and that will talk just about anything, Java, HTTP, SOAP. You can talk to it using Perl, you can talk to it using Python, you can talk to it using Lisp, of course. There's a lot of stuff here. And we have a guy who just loves to build those interfaces, so if you have needs for additional ones, well, you can probably be persuaded. So what's it for? It's a platform for information integration and use, and that's I've already said, so we'll move on. How do we go about building the knowledge base? Well, for the last 21 years, or for most of the last 21 years, we've been doing it by typing stuff in predicate calculus, right? Mostly first order assertions, some second order, some modal assertions. So most of those 2.2 million assertions were crafted extensively and by hand by a human being. We are sick to death of doing that. We don't want to do that anymore. What we want is to have Psych type assertions in predicate calculus by hand, quickly. So one thing that we've built is something we call the Factivore. It's a system for form-based fact entry. It's controlled by the KB. It allows for manual entry by untrained users of high-quality assertions. So they end up in correct, well-formed cycle, and the person entering it doesn't need to know about any logic. You can both manually specify these forms, or Cyc can make them up on its own. If you manually specify them, they're somewhat better. So here's, for example, a form for finding out about businesses. We've told it there's a business called International Business Machines. It asks you for product type. You can type basically any product type that Cyc knows about, and it knows about 287,000 concepts. So there's a good chance that it will know the one that you are trying to put in. Here's an example of an template for an induced Factivore form. In this case, it's asking for information about Yasser Arafat based on other famous people that it knows about. So, for example, it's asking what style of artist he is, because a lot of the famous people that Cyc knows about have been artists. This might seem foolish, but if you asked us about Nelson Mandela, for example, that would be a perfectly reasonable thing to do. As you gather more information, as you gather more knowledge, of course, it will be able to do a better job of inducing them. We have been using this system internally to actually do all of our task tracking for our Cyc projects, and I'll show you some examples of the reason that we've been doing that. We've been doing it, both to try and do a better job organisationally, but more importantly to fill the knowledge base with huge numbers of ground facts, because we want to see what we can do with huge numbers of ground facts. What do you do with Cyc, with this information in Cyc? Well, we have things like, you can type in general questions into the system and get them to answer it. Because it doesn't know everything yet, the hit rate on that is not particularly good. We have this other system called the query library, which allows you to take component queries, assemble them together semi-automatically into full queries. They're explained this way not because this is the best that Cyc can do with natural language generation, but in order to make them easy to modify if you want to change the query. So, for example, if you want to change the query from change embassy into public building or swimming pool or anything like that, it's straightforward, and it's generated so that it's straightforward to do so. You go off, ask, and it tells you, well, Al-Qaeda has attacked an embassy, and of course, because it's based on formal deduction, it can give you a proof of your answer. So Al-Qaeda has attacked an embassy because this particular bombing was carried out by Al-Qaeda, and Al-Qaeda is a terrorist group, and that embassy is an embassy. And this English is completely automatically produced from assertions in predicate calculus by the system. So that's sort of what Cyc is and where it's been. Where are we going? Well, where we're going is towards automatic knowledge acquisition. So basically, the idea is that it's very hard to learn a lot unless you already know something. Like, knowing something provides an inductive bias for acquiring the knowledge that you need to know a lot. So far, we have been sort of putting in knowledge at a sort of constant low rate until Cyc knows a certain amount. We hope that we're at the point now, and in fact we are to some extent at that point now, because we are autonomously adding some knowledge to the knowledge base, where what we've put in by hand allows us to start accelerating the rate of knowledge acquisition by automation, and then eventually you run out of what you can learn by, well, what I'll talk about in the third half of this talk, which is why I'm talking quickly, is learning to read and gathering knowledge acquisition from high quality reading. But eventually, there's only so much out there on the web. Eventually you run out of stuff and you have to start doing learning by discovery, which would take this project full circle, because it originally came from AEM, which was a discovery program that Doug wrote back in the distant mists of time. Sorry.
Could you say a little bit more about that magic crossing point? I saw that same slide, exactly. In 1991 was the Louis test, and I saw it again in 1993. The first time it was about 2 years.
Well, one of the things that has changed is a natural language system which is beginning to actually work and be effective. So we can actually go out and sort of understand some of the things which are there in text. Another thing that's changed is an increased, another thing that's changed is that since 1991 there has been 14 years of research in machine learning and natural language processing. And basically that matters, right? There are techniques now that didn't exist in 1991 and which are very useful for use in knowledge acquisition. And another thing that's changed, I think, is just a change in an increase in our commitment to fulfilling the original dream of Psych, which is, that the handcrafted knowledge should act as an inductive bias for knowledge acquisition, right, as a support for building a general AI, rather than be an artifact, with its a self-justifying artifact. I think for some time we were concentrating to some extent on just the mechanics of representing things well and being able to reason with them, without thinking hard about really now where could we get to in terms of automating knowledge acquisition. So I think it's I think that the slide, it wasn't true that it was 2 or 3 years away, and I'm not sure that the claim was always that it was 2 or 3 years ago away. It's certainly the case now that we're concentrating on that transition very heavily indeed, and I'm not sure that was the case in the past. Right. So the central hope here, and the hope which is beginning to show fruit, is that Psych knows enough already to perform autonomous learning of knowledge. So what we've been doing recently is a sort of loop where we're trying to acquire ground facts. We apply logic programming to induce rules about them. We validate the rules, then we pass these into the question answering interface, and by finding out when Psych makes mistakes, we will be able to validate or invalidate the rules. At the moment, we're doing an intermediate step in here where we validate the rules via rules rather than by their use. Oh yes, of course we do. Right. Yes, but I'm not actually going to talk about that in this talk. If you want to know about that, come would be to a NIMD PI meeting, for example, or an Acquaint PI meeting, where we talk a lot about what you can do with this sort of knowledge in terms of supporting human intellectual activities, and in particular intelligence analysis, since that's an important thing to do, and since the people who do it like to fund research which will help them. Right, so current research on machine learning. So in the past, we've sort of added knowledge to the knowledge base by reading documents, encoding them in sort of the most general form, and typing that stuff in predicate calculus. We're trying to use what's already in the knowledge base now abductively to think of which might be true and to find out whether they are or not. We're then trying to use the facts that we acquire by various applications of reduction for rule acquisition, and then finally we're trying to learn meta-knowledge about these rules, about the knowledge that Psych acquires in this way, which will allow it to automatically validate it itself, rather than having to ask human beings. So, as I said, up till now, the sort of path to getting knowledge in Psych, you read an article such as this rather poor Wikipedia article on croissants, which I think talks about things like chocolate croissants, which don't even exist. You take it and you break it down into what we call English zero, like simple statements of fact. You encode them in logic. So that gets you stuff into stuff into the knowledge base. As I said before, we now have straightforward way of entering those sorts of ground facts into the knowledge base. Here's a task for the project that did this research, saying that we should work on using principal components analysis to try and find which terms are used together in rules. There are now thousands of such. Underneath that is sort of the sum of the stuff which ended up in the knowledge base from using that interface.
Can you tell us a little bit more about English era? What that's like?
No, it's not interesting. It's the past. We then take those ground facts, the stuff that's already in sight, the 2.2 million or 3 million or whatever it is today, assertions, and we try to use them inductively to find out things which might be true and validate them either by looking on the web or by asking human beings. So the idea here is that we look for failed subproblems in inference. That's sort of a driver for what you should try and find out inductively. So Cyc's trying to solve some problem, finds a subproblem it can't do, it guesses what the answer might be, and then it tries to confirm that. We actually use that. In inference to have. We've got a mode where if it can't solve the problem at all, it'll just make guesses until it can and present those possibilities to you. I'm not going to talk about that in detail, but it's actually kind of cool what happens when you use abduction during deductive inference in a large knowledge base. So imagine that we have a inference problem where we have to find things, what groups is Osama bin Laden a member of. So for an example of a possible binding for is a Osama bin Laden X is a Osama bin Laden married. So is he a married person? That's how we represent attributes in Psych by collection membership. Some will be true, most will be false, but if it's doing a good job of abduction, virtually none of them should be nonsensical, because since Psych is a common sense knowledge base, it should be able to prove that the nonsensical ones aren't true, a priori. So we generate these abduced facts, and we verify by checking with a person or doing NL search. That's what abduction is, and if you don't know that already, you probably wouldn't be here. So we do this by taking seed queries, from deduction. What is Osama bin Laden? Whom does Hamas consider an enemy? Who considers Egypt an enemy? We use the knowledge base and abduction in order to work out things which might be the case. And we do this by a mixture of abduction and induction. We actually use information about the probability of things occurring in the knowledge base in order to sort of sort this here, sort these possibilities. So Psych thought, for example, that Osama bin Laden might be paraplegic. He probably isn't, but it's a reasonable thing to think. And if it did know that, it would be inferentially productive. So that's another driver for it.
Reasonable things and things, Michael. I mean, if I take anybody, pick a name of anyone that I don't know, it wouldn't be reasonable for me to think that that person is paraplegic.
It's not unreasonable because it's possible for people to be paraplegic.
It's possible that, they have free breaths or,
Right, so in fact,
all sorts of things.
So in fact, the point of this, or the long-term goal of this, is to get better at working out which of these possibilities to ask about, right? And only by asking things like, is he paraplegic? So yes, no, possible, implausible. Are we going to get enough ground facts to be able to work out what the probability of someone being paraplegic is? What's the probability that someone will say yes if you ask it about a random person for whom you don't know the answer? And that's what you should use to drive the order in which you ask these sorts of questions, and to drive the decision about whether to ask a human being or go and try and find it on the web. So to take this particular case, if it's true of a famous person, there's almost certainly an assertion to that effect on the web. Right? So you should prefer to go off on the web and do it. Using it in that way, but that's sort of the future plan. Is he authentication protected? Is there a password to access them? That's ridiculous. Right? And Site should be able to prove it.
You said in answer to my question before that the magic point has occurred because essentially something is changing in the world because you have changed from an inward-looking project building your
I'm not sure I'd characterize it that way, but okay. Right.
So when you do that, or when you do this sort of knowledge acquisition in large scale, you have to methodologically work it up multi-colleges, especially
Yes.
as you said. So if you don't start tagging likelihood of probability from the beginning, you're making methodological mistakes that's going to bite you more and more later.
I don't believe that that's true. Every assertion which is entered into the knowledge base, especially, is entered in, tagged with the person who entered it, the source from which it was derived, and when it was entered. And in the case of the of this abduce and induce knowledge, the mechanism which was used to abduce it. So, since the probabilities aren't currently available, we can't actually say what they are, but we certainly have the meta information available for going back and saying this came from the New York Times, for example, via information extraction, and over time we can learn what the likelihood that facts which are derived that way what the likelihood of truth of facts derived in that way is, as compared, for example, the likelihood of truth from facts that come from the New York Times, which have been entered through the factor board by me, which I believe would be highly reliable. Right. So
a level 2 that just says a factor being entered by person is number 1. I go to the room, I run Google just to see how many sentences I get for the fact and for the counterfactual of that fact. And if it's the right ratio, I accept it. And if it's the wrong ratio, I don't. And if it's sort of in the middle, I give it a sort of 0.5 probability.
So I'll talk about what we, in fact, we're not using the probabilities, although that's sort of an obvious thing to do once we're gathering enough ground facts. We are doing a different method of testing for reliability against Google, both for the facts that people enter and for facts which are acquired from the web. And I'll talk about that a little bit later if I get to. So a validation interface that we use. We put up the people get to say that it's incomprehensible, it isn't, that it's ridiculous. And then after answering that, they get to say how likely it seems, whether it would be worth knowing if it were true, because there are some things which, while they may be true, are just not interesting, and whether or not it's true or not, and if it is true, what's the source that you use in order to validate it's true. So why are we gathering all these ground? Useful, these people who pay us to find out about, to help them with intelligence analysis, actually, would like to know whether Osama bin Laden is wealthy, or they'd like systems to know that. They already know that, thank goodness.
Based on what you want to do. So how you can, I just want to come up. If you talk about how you what characteristics.
Right. So at the moment, we mostly drive it by inferential productivity. We work out how many rules would be enabled to fire about if this assertion was asserted in the knowledge base. The better way of doing that, if you had a system which is deployed, is actually to do what I said and look for failed inference problems and drive knowledge acquisition to support not failing on failed inference problems. So if you had a lot of queries which were asking, for example, could Osama bin Laden afford to buy a nuclear weapon, right? So hopefully Cyc has enough rules in order to find out that if he's wealthy, that's at least plausible, but it might not know that he's wealthy, so you should drive the knowledge acquisition from the fact that you're trying to solve a problem which relies on that piece of knowledge, or which could rely on that piece of knowledge. So how do we go about building rules? Well, we select a topic, we find related concepts, and we do this by applying some statistical to the contents of the KB as it stands. We then gather facts related to those concepts. We use inductive logic programming in order to try and find rules. We then validate the rules. We filter and sort the rules, and then we filter the rules using inferences that we try to prove or disprove the rules that we come up with, and then we apply human review, and we cycle around on that. So, for example, what I didn't mention is the two things which are, I think, major research problems in applying inductive logic programming. Generally, ILP has been applied for in areas of mathematical logic with small vocabularies and small numbers of assertions. That's really helpful. It can produce exponentially many possible rules in the size of the vocabulary and in the size of the background knowledge. Exponentially many when you've got a vocabulary of about 300,000 things and about more than a couple of million rules in the knowledge base is an awfully large number indeed. So what we're trying to do is develop techniques to cut down the search space for logic programming. We're not currently doing particularly novel research on the actual mechanisms of logic programming. We're applying standard techniques like FOIL and ELIF after we get down to the sort of things that you might try and find rules out of. So if you're looking to make rules, for example, about relationship between mothers and children, and Cycorp already has a large number of such rules, but it could do with more. By looking at the structure of the knowledge base as it stands, we find these terms and predicates which seem as if they might be relevant to using rules. And these are the ones that we try to build rules out of. And I'm not going to talk in detail about that. If there aren't papers that you can read about it now, they're on their way. They're in press. We then go off for those terms and predicates and try to gather known facts, either just by looking in the by going off and doing abduction, going off and doing web searches and so on. We then, so there's this, I'm going to go in more detail into this than I had planned because it talks to the point that was made before. So what we do is we take the terms that we're trying to use, we take the information that we're trying to find. We generate using the NL generation mechanisms in Cyc a web query that we think will find pages which are relevant to the fact that we're trying to obtain. This is sort of very much like know-it-all. In fact, if you imagine know-it-all with a different validation mechanism and sort of develop an embarrassing ignorance of each other's work, then you'll understand this. So we go off and do the search for a page that might contain the information. We then isolate the sentences in which the information is probably found, and we do a parse of those sentences. We then suppose that this might be true. We then go off to our natural language system and say, don't just produce a query, right? Generate a full representation of this fact that you've allegedly extracted from the web, such as that Jaish al-Muhammad is the founding agent of Jaish al-Muhammad is Masood Azhar, which we got out of this sentence. And we try and we use Cyc to generate its best English for this. So it would probably say that Masood Azhar is the founder of Jaish al-Muhammad. We then go off and do another search against Google to see if we can find that claim directly stated. If we can't, we don't bother using that piece of knowledge. We keep it in the knowledge base as something that it should try and validate later, but we don't view it as being validated. And at the moment, after they've passed this test, they get reviewed by a human being for addition to the knowledge base. Here, we also have another step where we don't bother going off to Google. We first ask Cyc, did you already know this, and can you prove that it's false? And that works quite often.
That second Google query has to match exactly. You have to find a document that has precisely that sentence in it.
At the moment, yeah.
How old is this effort?
Actually, let me take that back. It may be that we check for large numbers of hits which are like that sentence. I don't remember the details of that in its current state. It's changing all the time. I know that we have gone after exact matches. I don't know if we've generalized from that yet. Sorry?
When did you guys start doing this thing?
The first extensive run of this was over last Christmas.
Just a question back on using human annotators. So if it's the same Osama, to be perfectly clear now, it seems like there's so many facts that you get asked about that, like, does he have cirrhosis of the liver? Like, does he have toenail fungus? Is he a monk? And there's, like you're saying, there's an exponential number of things that you get asked. So how do you, and given you have limited human annotator time, how do you choose which one's the most useful to attack?
Well, that's why we're asking the annotators whether they're useful or not, because we intend to apply machine learning. In fact, we intend, amongst other things, to apply inductive logic programming to say, for example, if a question is, I don't know, let's see then, I don't remember what the predicate for saying that someone has a disease is, but if the assertion is asking whether a person has a particular disease, then it's probably not worth asking a person about it, right? So that the person will probably click on, this isn't worth knowing. We also, of course, just want to gather statistics on whether or not the people know the answer to that. It's not worth knowing if no one knows the answer to that sort of question. So at the moment we're being asking those things. I mean, it's not just crazy, right? It only asks things where psych can't prove that they're ridiculous things to ask. Right? And there are all sorts of argument constraints and interarg constraints and so on, and disjointnesses in the knowledge base, which allow us to eliminate almost all of the possible questions that psych might ask you. It's just that there's quite a lot left. And what we're trying to do by so that we can be more and more picky about wasting human beings' time. And I think that this process should bootstrap pretty quickly once we're able to put this out in front of a large audience.
This is a fact, Michael, and your use of the example is Osama bin Laden, a monk, is a very interesting one, because technically Osama bin Laden is not a monk, but you can easily imagine articles describing him as monastic.
Right.
And so he's not a monk. Factually, he's not a monk, but it wouldn't be the wrong word to use.
Yes, I hope in about 6 months' time to be in a position to give an entire talk on why NL people have been foolish not to take metaphor seriously, and to believe that you can get away without, that you can process almost any sentence without understanding metaphor or metaphorical uses. But that's not this talk. I agree. But that's. I'm saying that I believe I will be able to do metaphor computationally. I can't do it yet. I have a plan. I have a scheme. This is supposed to be the visionary sort of talk. I have a vision which is so visionary that I'm not even going to talk about. I'm going to talk about a less vision. But yes, I believe it. I believe it can be done, and I believe that there are computational mechanisms using background knowledge which can give us at least some traction on it. But back to rules. So Psych comes up with a rule like this. Which says if A is marital status of C and A and D are friends and D is occupation of B, and it's false that A is a DC1, then A is occupation of B. And what the heck does that mean? Well, people can't actually validate that, but if you translate it by giving a ground instance of that rule, using things which are known to satisfy the constraints on it, if Anne is married and Anne and Dave are friends and Dave is a plumber and Anne is not a programmer, then Anne must be a plumber. Well, no, right? So incorrect rule.
So what proportion of rules constructed like this are not true?
I'm getting to that. We have a slightly more sorry.
It just seems to me that some fact is tied to time. So some fact that is true now might not be true.
Yes, Psych has an extremely complicated mechanism for handling temporal contexts, and we have a complicated mechanism for handling contexts and for reasoning in contexts. And there's a system for dynamically creating these contexts, these micro-theories from times with granularity that I'm not going to talk about at all. But yes, all of these facts which are entered into the knowledge base, Psych knows which ones ought to be temporarily qualified. Many of the ones which were entered in the past aren't and should be, and that's actually going to end up being something that we need to tie up with machine learning, because we're not going to go back and do that all by hand. So we've got a mechanism for representing that, which is good. We've got mechanisms for reasoning with it, which are good. We're entering, when we enter new facts into the knowledge base, we temporarily qualify them so that it knows that despite the fact that Abraham Lincoln is a president in 18 whatever it was, he's not a president now and so forth. But we don't yet have a mechanism for going back and adding all that information to the stuff in the knowledge base which was incorrectly entered atemporally. We will make sure that this works with temporal qualification. We're not concentrating on that at the moment, and for that matter, other types of contextual qualification. It's not quite true that we're not concentrating on it. When Psych asserts these things into the knowledge base, everything in the Psych knowledge base needs to go into a particular microtheory, into a particular reasoning context. So we do have some automated methods for working out which one it should go into. They're not perfect yet, but they're being developed.
Just one?
Just one what?
It goes into just one microtheory?
No. It can go, at the moment, the automated methods try to pick the best one, but that's clearly, clearly an incorrect thing to do. Ultimately, if the microtheory structure is correct, it should be possible to put it into just one, and the relationships between microtheories should be such that it is inherited into all the other ones which it should be inherited into. You should never really need to assert stuff into multiple microtheories. I doubt that that's not true at the moment, so that constraint wouldn't be observed. The last interface I showed was for naive users. Here's another rule in an interface for sort of professionals. An example of this one is Zacharias Moussani was born in France. Mustafa Kemal was his religious teacher. Mustafa Kemal was born in France. We don't know whether he was married. We don't know any friends of Zacharias Moussani. Then Zacharias Moussaoui has been in France. Well, that's kind of a rule, but it's got all this nonsense here due to the fact that we just don't have. LP will try to explain the ground facts it's got. Right? We don't have enough ground facts about tourists, although we have a large number of ground facts about tourists because we have a large knowledge base just on that area, but we don't have enough ground facts to eliminate these as things which are relevant to deciding that this guy's been in France. However, if you could remove these conjuncts from the rule, you'll get a perfectly good rule which says that if someone was born in a country, then they've been in that country. Hopefully a rule that Psych can prove it already knows, but not necessarily. So early results. We ran a test on this where we created about 150 rules in a variety of domains, well, in task management inside Cycorp and in allegiance and affiliations for basically tourists, because that's where we've got the most information and the most ground facts. The results were reviewed by 2 people. Overall, 7.5% of the rules produced this way were good enough to assert directly into the knowledge base, and 35% of the rules needed quick editing of the sort of eliminating conjuncts before they were able to be assertable. So what do these rules look like? Well, they look like that. Can everyone read PsycHealth? No. All right. So what this first one says is if some percentage of someone's time is being requested for a task, and that task is requested by the primary project that person works on, then their task will be assigned to that task. Their time will be assigned to that task. So if you're requested for the project that you mostly work on, then you'll get assigned to that task. Now that's not always true, but it's default true, and Psych didn't know it. People participate in the projects they manage. One claims this when one's writing a statement of work to DARPA, and it should be at least somewhat true. Psych didn't know this already. It does now. And people are assigned to any task requested of them via project, their direct supervisor managers, i.e., people are kind of corrupt. You know, you don't think of all the projects in the company fairly. You just take your people and you assign them to your tasks, whether or not that would be the best thing for them to do. So these are all, you know, perfectly valid rules. Some of them are just default true. All of them are just default true, but they're perfectly reasonable rules which could be used in reasoning about Cycorp's business practices.
What level of expertise is needed for people to modify? So you say people who can be experts in main modifications, but could main experts make simple modifications?
I don't think that you should have the main experts interact directly with the rules at all. I think that you should have them interact with these grounded instantiations of rules, perhaps several of them, and to say which parts of those are relevant. I think you ought to be able to add, for example, tell it a term, which is something that it should take into account, and then have it rerun the ILP process. Have it, or even a simple statement which it should take into account, or that it should conclude, and then have it rerun ILP. So basically, the scheme here to move towards is don't try and make people write rules. You guys tried that in RKF. You know, it seems to work, but you have, you know, George Takuchi does it. He's actually found a domain of rule writing where it does more or less work where the rules are simple conjunctive rules and where you work backwards from the conclusion to the antecedents. That seems like people can sort of handle it, but in general, you know, the rules of the sort that logic-based systems use are not the sort of things that human beings are good at doing, and we shouldn't try and make them. You know, what human beings should do is give the system hints, and then the system can do ILP to find rules which are actually consistent with the rest of its knowledge base.
I wonder then, so we're looking at these rules and we're looking at trying to induce some new facts that we need for this rule. What about all the other zillions of new facts that we induce for this rule, some of which may be bad, even though the rule itself looks correct because it's some other defects in the code?
Right, so one thing that we're going to move to doing in the validation process is when you have a rule and you said that you think it's correct, we'll actually go forward and do forced forward inference on that rule and tell you a bunch of the conclusions. Then the system will go off and use the Google type technique to try and validate some of those things on the web. If it invalidates them, then it will be suspicious about, you know, not only the rule but about you. If it does validate them, then it will be more confident about the rule. Maybe it will ask for confirmation, for human confirmation for some of those assertions. But you know, the other thing to do, of course, is just to take the rule and put it in the knowledge base, and sort of in a 2001 moment, you know, put it in place and see whether it fails. Right? If it fails, you know, the system can actually, it gives you the proof. And inside those proofs, which I told you before, you can actually interact with them to disagree with assertions which are used as just. So we'll learn from that as well.
Michael, on the previous slide, those induced rules.
I'm trying to get to the interesting stuff.
Says most likely. The rules don't say most likely.
They say most likely because there's a meta thing on them which says that they're default true. There are at the moment two versions of rules in Cyc. There are default rules and monotonic rules. So, and all of the rules which are created by the system are set to be default true by default, because what's the likelihood that it's actually going to come up with an eternal truth by reading the web? You know, not high. And you can learn hints to monotonic rules anyway. Clearly that's not sufficient, and in the, you know, what's the grand future slide, I will make clear that we are absolutely committed to using probabilistic reasoning. We're just not doing much of it yet. The final thing we do with these rules is to try and learn meta characteristics of them, because we're having people review them. What's the point of having these? You know, it's not good to just have people review the rules for the sake of adding that particular rule to the knowledge base. What you in fact want to learn, you know, how to make Cyc fish for itself, how to make it be able to decide what rules are bad. So we are trying to analyze the rules which are denied and to see what's wrong with them. So for example, if you take this rule here, its graph structure, i.e. the structure of sort of the terms and the predicates which connect them, has the characteristic that there's this sort of well-connected bit over here, and then there's this tail over here. So one thing that we've observed is tails like that, where the things are just strung together for the sake of being strung together by the ILP system. Much of that stuff's likely to be irrelevant. So the system could just reject all rules with a long tail like that. You know, sometimes it'll be wrong, sometimes they'll be perfectly good rules, but it's better to throw out rules than to ask a person.
Propose that as a general heuristic in the ILP literature?
Not that we know of, not that I know of. Right. Right. And we'll see whether it holds up, because again, I believe that that's made it into one of the papers that we've got in press at the moment, so people will be able to challenge us if they've done it before. I don't know of any such claim.
The rules you're learning seem to be sort of conventional shallow rules. You've thought at all about how to program those to the deeper explanations of a language that would be more general?
Yes.
Born is a physical activity. Explain maybe in a lecture why the shallow relationship holds. Then you might be able to come up with much better rules.
So in fact, that's one of these sort of fundamental changes, right? In in the middle days of the Cycorp project, there was a great concentration on the upper ontology and getting that completely correct, right? What we're focusing on now is these ground facts, right? And then working outwards from them. If you think about ground facts, these rules are sort of ground rules in a sense, right? They're things which are explained shallowly by ground facts. But there are all sorts of techniques that you can use to generalize them. So, for example, if you recognize that there are repeated substructures in the antecedents of these rules, you can produce a rule which generalizes that and replace it by a predicate which represents the conclusion of that rule. That's like sort of the simplest example. There are all sorts of things like that which we've thought about. We've got enough on our plates at the moment in these shallow rules, but we're certainly intending to get to the point where we can bootstrap all the way up to very general knowledge this way. It's not going to be trivial, that's for sure. What do we do? It's a research program. It's not running all of the time. It's reasonably fast. I can't actually give you an answer. If you send me an email, I'll ask the people who are actually doing this to tell me how fast it is. But it's it's of the order of seconds per claimed rule. So the bottleneck at the moment is the review process. So as we connect the pieces up together and have it go off and try and find supports for these ground instantiations of the rule. So you can imagine if you've got a rule for which you know ground facts for all of the antecedents and you reach a conclusion and you go off and try to prove that conclusion by searching on the web and you succeed and you do that for multiple instantiations, then you should be able to assert the rule directly. So that's the thing that we're planning to do next. We haven't done that yet. And that's a big bump. So at the moment it's like how many rules a day, it's however long it takes people to review them. I don't remember what that number is. It doesn't take all that long. It's certainly faster than the approximately 3.6 hours per rule it takes for a good Cycorp ontologist to produce them.
Yeah, I'm imagining if you get to the stage where you learn tens of thousands of rules, candidate rules a day, and you do the inputs and verification, you're talking about a certain human annotation, checking, validation process, which is a very different thing from anything done. That's when this really gets important.
Right. Yes.
Like before, now you're just saying interesting ideas and try to experiment. So it would be very interesting to hear what happens then. What's the percentage? Is it really
Well, that's when we're in this part of the curve, and it's like when we get over here, that's when the really interesting stuff starts to happen, and we have to deal with scale. And we bootstraps. What happens when we're half a meter off the floor? I mean, that's the interesting question. And to do that, for example.
The problem is, the reason I'm supposed to take this is that Celtic has 21 years of being in, we're almost there to George Starting his Scotland these days. There's a lot of interesting things that have been there, but we never get numbers.
Well, there are two answers to that question. One is you have research site now. You can and the other is these numbers, you'll be able to read the papers. I've given you the number for production. This is admittedly work that's only starting. We're not running this in large-scale batch modes. We will be running it in large-scale batch mode, and we'll publish the figures that we get from that. We will be trying these ground cases derived from on the web for public verification, and we'll publish the figures that we get for that sort of verification. Really committed to publishing the results and to empirical validation, and projects evolve over time, right? And the site project has certainly evolved recently. So what's the future? I'm going to talk quite a bit about autonomous acquisition of reading skills. Something that's going to be essential to moving Psych into being the full AI that we want it to be is moving from just deductive inference to mixing logical, probabilistic, and other representations. We're starting to work on that. Applying machine learning absolutely everywhere, including in the operation of the inference engine. Applying agency absolutely everywhere, including in the operation of the inference engine. Starting to work on, we're actually involved in a project called ASIP with some people here at ISI. We're trying to develop highly efficient cognitive hardware so we can actually run this stuff fast enough to matter. And maybe if we're lucky, we'll do some work on speech and vision. We've got some incipient maybe projects on that. So I'm going to talk. Does anyone know what the time is? Right, so I've still got a little bit of time, and if I go quickly through this, there'll still be some time for questions. So I'd like to, because this is the stuff that we aren't doing yet, we're about to start doing, and I think it's going to be cool if it works. Right, so what do we do in Psych for natural language processing at the moment? Well, we can strengthen information extraction results. So a normal AI system will say that this phrase refers to a person, for example. We can say that this phrase means that Basilev is a leader, that he's a Chechnyan person, and that he's the leader of some revolt organization. What can you infer from something, from the fact that someone's a person? Well, a lot, but none of it interesting. What can you infer from the fact that someone's a Chechnyan or the leader of a revolt organization? Well, you can infer that you should be scared of them. And being scared of something, I think, is perhaps the thing which determines at base what things are interesting. So we can already do. Fun? Yeah, it's the is there a tiger view of the world, right? Which I find somewhat convincing. So that's already something, but we can't do it generally. We have an elementary text reader which can take a sentence like Evelyn Mandela, the first wife of former President Nelson Mandela, died yesterday in Johannesburg, out of a news story, and get an interpretation like this, a somewhat stilted interpretation. So it's it hasn't got everything out of that sentence, but what it has got out of it is right. Yeah, well, so it's an AI. What do you want? It doesn't think like we think. And that sort of mixed initiative process, because you can take Nelson Mandela, and that will tell you what cycle reading him, and you can add extra information about him, such as that he has a married relationship at a particular time with Evelyn Mandela, at which point it would be able to get more information out of the sentence because it would understand the relationship. We're trying to get beyond that point. We're trying to get to comprehensive reading, because the pausas and the semantic interpretation, all that stuff was either written in Lisp by hand or written in Java by hand, C by hand, or added to the knowledge base by hand. To hell with that, right? Psych should be acquiring the knowledge that it needs to read natural language text. So I talked about this stuff down here. I'm now going to talk briefly about our plans for autonomous natural language skill acquisition. So the basic idea is that correct understanding of text requires knowledge, huge amounts of knowledge. Much can be acquired while actually doing the process of reading, and while the process of reading imperfectly. So the scheme is to massively overgenerate the feasible interpretations of text. Now, whether you actually overgenerate them or not, or you just make them admissible, is a different question. You look for evidence for those interpretations in later text, or perhaps sometimes in previous texts. Since you're a computer and you can remember everything, you don't have to act like a human being. You train the hypothesis generation technique using the evidence that you found in later text. In the cases where you over-constrain, i.e. you get down to only a single interpretation or no interpretations, you generalize the mechanism used to over-generate, and you loop through this continuously until you've acquired everything that you need to read. Now, this presupposes that you can already understand a bunch of the text. It presupposes that you've already got background knowledge. It might be interesting to run such a system tabula rasa, but we don't intend to do it. So here's an example of some text that you might want to read. In fact, I think that Wikipedia is like the best example out there at the moment of the sort of text that AIs should want to read, because there's a lot of it, and it's trying to give the sort of information which you might actually use in deductive inference. It's in a more pure form. So here's a star is a large glowing sphere. This is found in outer space. There appears points in the nighttime star, in a sky that twinkle because of the effects of the atmosphere, and so on and so forth. This is hard to understand. In particular, things like points appearing is hard to understand if you just take the base semantics of the word appear. It's very hard to understand. What does it mean to appear as a disk? It doesn't actually appear. It seems to be a disk. What does it mean to be found in appearing in the nighttime sky? What is the sky? Right? These are hard interpretation questions that no amount of syntactic information processing is going to solve for you. So what do you need to know? Well, you need to understand this. Just the first sentence of this. You need to know, for example, that a statement like an x is a y can translate definitionally. It can mean every x has the attributes y. It has an existential interpretation. There is some x in collection y. A ISI staff member is Tim. So lexical access doesn't work well in humans, or at least not on this one. What else do you need to know? You need to know that x is found in y can mean x is located in region. It can also mean a parts location interpretation, such as the carburetor is found in the engine of the car, or an ingredients interpretation, tomato is found in pico de gallo, and all sorts of other interpretations. You need to know that outer space is far from Earth's surface. Large, when used in this context, may mean celestial scale. Like, large doesn't have an absolute meaning at all. It's subject to interpretation. You need to know what a sphere is, or what the term sphere refers to. You need to know that visual attributes like red or usually apply more or less uniformly to the thing described, and so on and so forth. So take the first two pieces of knowledge about how to interpret text into a logical representation. What we're trying to do is an application of example-based machine translation to NL understanding. So if you take a sentence like a star is a large glowing sphere that is found in outer space, and you already have a sentence like a carburetor is a part that is found in engines, and a bunch of other sentences which are like that, you can generalize that, and you've got an interpretation for that sentence. So somehow, by some means or another, you've already got a translation of this into logic. Perhaps because the system generated the sentence itself from the logic it has, because someone told them to do that. Perhaps because it said something which amounted to a claim that this was true. For example, every carburetor, every engine has a carburetor as a part. Might well be the sort of thing that Cycorp would say in the course of a proof. If we start asking people to rephrase everything that Cycorp uses in its natural language, if there's a better way of saying it, we might, for example, easily get this sort of sentence. Right? Assuming that you've gathered a number of such translations, that you've got, the sort of translation base which is used in example-based machine translation, you can generalize that sentence to, a variable 1 is ignore this part that is found in variable 2. We've got the corresponding Cycorp here, which relational instance object found in location x1, x2, which means that every instance of x1 is found in the location x2. So that grounds out into some real first order code. There's no significant object found in location is an existing site predicate, which means
Is it different from object and location?
I think that it doesn't mean that it's there. It means that that type of thing is found in that type of location. It's not. This is a type predicate, not a instance predicate. So we're talking about types here. We're not talking about instances. Now, if you said that a particular instance was found in a particular place, you'd have this would map onto a different predicate. And you'd need, this template actually would have constraints on it which allow you to distinguish those two cases. All of the predicates have type constraints that you can find out all about them in excruciating detail by looking in research sites. We clearly would use them in these templates as well. I'm not going into the detail.
It seems like what you'd really want on the previous slide, and there's really two micro-theories going on there. One is kind of true astronomy, and the other is astronomy as it appears, kind of naive astronomy as it appears, where the fundamental fact is you've got a bunch of things embedded in the sky that have various shapes and light. And what you want to do in response to that paragraph is to figure out that the first sentence is really about true astronomy, the second is about naive astronomy, and kind of fit it into the schemas that hopefully you would already have on each of them.
Although I think that the things, apart from this sort of quasi-metaphorical use of appear, because I'd prefer that, talking about the more distant future, I'd prefer that almost all terms have only have only the senses that they actually have, that we don't unnecessarily generate senses for every metaphorical use.
The theory in there is to say that these two sentences have to do with naive astronomy rather than real.
Right. And the fact that there's a quasi-metaphorical usage or a sense extension on appear used there should mean that you have to interpret those sentences differently. And as I said, I've got an incipient theory about how one might do that. But I agree. I agree with your general point is that you actually have to do quite a lot of work to understand that paragraph. What we're trying to work out, and I'm not going to talk in detail about how you handle that and about sort of the role of I guess these frozen metaphors versus non-frozen metaphors, and whether or not you should admit them for EBMT, and what sort of templates you ought to try to learn and which ones you shouldn't, or what sort of translations you should try and learn and which ones you shouldn't. I'm just going to hint at this. I hope that once this gets started pretty quickly, we'll be able to take what was in the proposal and write a paper about some results that we get from it. But that'll take about a year after we get started. I don't know how this is all going to work out.
Body work on takes parts and the people learn this kind of mathematics from non-metaphorical language to the next one.
I understand that.
Yes.
So I'm not actually planning to. So the goal here is, of course, not to handle all of the language. The goal here is to handle an increasing amount of the language and to be able to get some things out of the language which help you to interpret more things in the language in the future. So, and then we can bootstrap up towards the metaphorical usages. But this star of the large glowing sphere, that's actually true. Up to whatever glowing means. So we can use, if we have this pattern, if we've learned this pattern by example-based machine translation, we can understand that all stars are found in outer space. We can apply exactly the same template to understand this sentence at a type level. Having done so, we better find out whether it's true or not.
Right, but give us multiple meanings for words, because like a star was in that meaning.
Yeah, you can assert multiple denotations on words in particular syntactic forms of words. So, in fact, my current belief is that we have too much polyphony, and if I were being purist, I would say that when you call a person a star, you're in fact applying a metaphor, and you might actually be able to infer stuff from that, like that people will call them brighter than other, other celebrities, and that you maybe ought to keep that information around, and at the risk of making systems so slow that even advanced cognitive architectures won't work with them, you ought to be processing that, because I think people do. And actually the psychological evidence on frozen metaphors is iffy. It's still an open question whether you truly freeze even things like a star as a celebrity, or whether you actually bring in the this metaphor between them as sort of being like a large and bright thing in the firmament and being a large and important thing in the domain of acting. But I'm certainly not going to get into that. Right. So we've read the sentence and we've got this fat relation or instance object counter relations in location star outer space. Cyc has known since December 11th, 2000, because it keeps that information around, long before this project started, that all astronomical objects are found in outer space. It also knows that a star is a kind of astronomical object. It had this time where it had a memory lapse, so I think it doesn't actually know when it learned this fact and who told it to it, but it knows that stars are astronomical objects, and it happens to be true, so I'm not going to worry too much about the fact that it doesn't know whom to blame for it. Using these together, using simple inference, which in fact Cyc can do very efficiently, we can in fact already infer that all stars are found in outer space. So that's a pretty good piece of validation. So Cyc already actually knew this. It didn't know it, it wasn't saved as a ground fact, but it could already prove that. So whatever the process was that got us to that was a pretty good process, because it enabled us to get something from text that we already knew. And that's sort of the crux of this. So using that, we can go backwards and say, okay, this is a good template. I like this template. Not only am I going to consider using it in the future, but I'm going to raise it above all the other which might have been applied, such as that ingredients template or the parts template. I don't know how much contextualization you'll have to do, how naive you can make the statistical model. These are all research questions, but this is the basic idea. Right, so let's go through another detail in a bit more, another example in a bit more detail. So a star is a large glowing sphere that's found in outer space. Well, Cyc already knows what sphere means. It knows when it's used as a count noun. It can be a sphere, which is like the mathematical object, or that it can be a spheroid, which is like a thing which is in the shape of a sphere. Right, but it doesn't know what glowing means. It doesn't. Right, so this is like a deverbal noun compound. It doesn't know how to interpret glowing here. How could we go about learning that using existing background knowledge? And this is a sketch because we haven't actually done this yet. Right, so Cyc's stupid, doesn't know that. Where can we go? Well, it does know that glow the word has a intransitive subcategorization frame representing. So this is a sentence which fits that frame. For example, the lamp glows dimly during operation. So it knows that there is a verb sense of that word. It doesn't know what the denotation of that for that word in that frame is, and right. So it knows that there's a verb sense of it. Further, it knows that there's a noun denotation of the word which corresponds to the emission of visible light. And it knows that because it induced that by looking at contexts in which the word glow was used, right? And looking at the verb which was used from it, and looking at the arguments, typical arguments of those verbs. So this was induced over data using verb arguments statistically and confirmed by a human in the course of an unrelated project. It knows that every wave emission of visible light has a partially tangible emitter. So this is part of our representation of complex situation types, or as you might know them, scripts. So there's a large amount of this sort of information in the knowledge base. It corresponds roughly to the sort of thing that you might find in FrameNet. What's the intangible part of the emitter? Information about. Right. It doesn't have to have an intangible part, but it's at least partially tangible, right? So whatever this thing is, at least part of it should be tangible. You can't create light out of nothing. Well, I can't create light out of nothing. Some people might disagree with this assertion. The intangible part of this is the meaning of the writing on the top of it, right? It's got a manufacturer's name, which Philips, right? So the intangible part of that light bulb is inter alia, the meaning of the word Philips, all right? The goal is to derive, well, we know that this thing, whatever it is either a sphere or a spheroid. The goal is to add this as the interpretation of glowing sphere, and we have already a bunch of the basis for this. We know that an emitter is required. We know that glow, the noun, means this emission of visible light. What we need is a general rule which says that the verb form of things which have a noun form of this, which can be used to represent events is often an event which is producing the noun meaning, right? So there's a noun meaning of glow as well, which is this diffuse illumination. We can learn if you look at how these things are used together. Words which both have a verb form and a noun form with the same form. It's often the case that one of them is talking about producing the other. And we know that one of these things is an emitter, so there is a production relationship going on. So the goal here is to be able to guess that this is an interpretation based on the background knowledge we already have. Now, I think that we can get to that goal. In the proposal, we've got far more detail about what actually is in Cycorp, which can get you most of the way to that goal. So it's a matter of can we come up with heuristics, very, very general heuristics, which allow you to hypothesize this and many, many other wrong things as possible interpretations of the sentence.
Can I take some questions?
I've only got about 2 slides left, so if that's okay. So what we can do next, so if we've got to that interpretation, what we do next is look at the rest of what's said. And if you notice, all of these things in black are sort of things which are consistent with the star being an emitter of visible light. So the idea is that by reading forward in the sentence, having come up with this as one possible interpretation, you can add strength to this interpretation. You can decide that, in fact, out of all the interpretations, there's a small set of them which are possible, which are consistent with the rest of the text, and that this is one of them, and you can reward whatever the heuristic was that allowed you to arrive at that interpretation. So immediate future work on this, well, getting it to start. The first thing we'll try to do is produce very general rules for trying to work out what the possible compositional semantics of noun compounds are. So, an example of a noun compound, ISI researcher, a researcher who works for ISI, but it could mean a researcher manufactured by ISI if that was plausible, right? So very general mechanisms for working out what those semantics might be and then narrowing them down. General rules for semantics of more adjectival forms, such as this verbal, glowing, more applications of EVMT for extracting meaning, and eventually general methods for handling analogy. And as I said, the more general future for the Cyc project is this, and I hope to start collaborating with many of you and perhaps working with some of you in the more distant future on realizing these goals. The distant future, of course, is to make a true AI, and that we're all working on. Any questions? Attacks? Balls? Jokes?
I had a worry, right? So it seems you can get hung up on anything, right? Is a star really a sphere? Well, not just spinning, blah, blah, right? So at some point you have to sort of let go, right, and just cruise on this looser understanding.
Right.
Any thoughts about how to pick that level and what's good enough or what's...
What's good enough? The only things that you need to extract from the text, right, again, what I think of, and this may not be true, but what I think of, the only things that you need to extract from the text are those things which are required to either prove or disprove interpretations of things which happen later in the text. I believe that if you extract all of that information from the text, and only that information from the text, especially the information which is required to resolve metaphorical usages in the text, then you will in fact get what people get out of the text. Now, this is a psychological theory. I'm no longer, I was an undergraduate psychologist and I decided not to do that anymore. Once we get somewhere in this, I think it will amount to a psychological theory of meaning extraction in human beings, which will deserve testing. Basically, the idea is that if you extract a certain knowledge base, what you used in order to understand more stuff in the same text or more stuff in later text, then that will be what you should extract. And if you never needed to use the distinction between a spheroid which is truly spherical and a spheroid which is oblate, then to heck with that distinction. Don't make it, don't try and learn it. In fact, how would you learn it? Because now it might be the case that you have another article about very rapidly spinning stars which which swallow up a planet.
So developing a great sense of what does and doesn't matter is sort of like a thing though, because it's like being over both domains and knowing what actually is. It's a good answer, but it's not. I don't know how to turn that into a computer picture.
Well, right. So the prescription is that it will generate every interpretation that it can, right? And then it'll try and eliminate them. Right.
So one reason why it's so hard to build something like a site is that once it goes reached a certain size, the complexity just becomes so intractable because everything is so entangled. And one little change somewhere can have a very, very severe influence on how it needs to perform. Now you're adding a learning component that actually, maybe not now, but the super adds rules to that at a very rapid rate. Increase the entanglement. And so how do you propose or how do you think that this complexity is really handled so that you actually get something that really performs?
Right. So the good thing is that if you look at if you decompose the knowledge base by how much generalization things give you, there's actually a small core of terms which are used to support most of the generalizations. You shouldn't mess with those, right? When you've got a large vocabulary, and this is sort of why we think ILP can work even though the vocabulary is ridiculously large. In fact, the terms that are used together, not every term is used with every other term. So at the lower reaches of the KB, the more specific terms, the lower frequency terms are only interact with a few things, and they interact generally with a few things in rules which are not used on most problems. So I think it's not going to be that bad for the first few years where we're moving up from ground facts to more general rules. Right? And those rules about people's supervisors and so on, it's conceivable that we might put them into the wrong microtheory, into some general organizational microtheory instead of Cycorp business practices microtheory, and that therefore they might reach wrong conclusions about who's going to be assigned to what project with ISI. But, so what at some level? And if we do put them in the Cycorp business practices MP, then, or they're actually correct in that MP. So if we gradually get better at placement of the assertions, and if we make sure, if we exercise caution in the sort of rules that we dare to induce until we get a lot cleverer about the techniques, I think we can stave off that problem. And I think we can develop techniques for working out how much effect a rule that a candidate rule will have on the knowledge base, right? So what its inferential effects are. And in fact, if you can't prove that it's false, then probably it doesn't screw things up very badly, right?
Well, there's the general issue, like everything is default. You never really come up, with contradictions anyway. You just come up with conflicting arguments. Right? So at some point,
So one piece of guidance, don't accept rules without review if those rules have large numbers of arguments. And I think that there are pretty straightforward heuristics for addressing this. The thing that I'm worried about is that running those heuristics may be intractable until we have things like these ASIP architectures. So I am a little bit worried about it. I'm worried about this, in fact, for the knowledge which is being entered by hand. People aren't computers. People can't even do as good a job as Cycorp at keeping track of the effects of the rules they're entering. And so far, we're not finding vast numbers of sort of false conclusions because of inadvertent contradictions. But it might be that if we had manually fleshed out the knowledge base sort of completely with common sense knowledge, that it would have rampant contradictions which would trip us up. It might be that in any large knowledge base that one tries to form, this will happen. This is an empirical question. It might be that if you use first order logic, you either have to have ridiculously specific interpretations of concepts, or you're going to get rampant contradictions all over the place when you try to do the sorts of reasoning that people do. We've never had reasoning artifacts which are large enough to answer that question. It's worth worrying about. And I think that's actually that's one of the worries which is driving our desire to move towards probabilistic representations, where you can have some sort of ambiguity in the meaning of concepts. But then you throw out having good inference procedures, right? Or at least you postpone having good inference procedures. That's beginning to fall into place now. So yeah, it's a worry, but I think it's an addressable worry in the short term, and either it will become a very big worry or no worry at all in the large term. Paul, I think that you...
Yeah, I was thinking about a note the school nurse that my daughter brought from the other day that warned of abdominal discomfort. And I asked her, what does abdominal mean? And she said, extreme. It wasn't an implausible interpretation given the sentence. Contrast that with a little experiment where children are asked to go over and pick up a tray. And there are two trays. One of them is silver, one of them is red. And the experimenter says, go get me a tray. I want the chromium one. And they don't know what chromium means, just that she didn't know what abdominal means. But she got it much, much faster in the chromium case than in the abdominal case. And the reason is there was something to look at. The language was actually describing something. There was something that the language was about. And my concern with all of these efforts to try and learn language from language alone is that there's nothing the language is about. There's no scene being described. And you're sort of doing your best. You're saying, well, as a proxy for what the language is about, I'll see whether I can be consistent with later language in the same paragraph.
And revert your knowledge.
And revert. But, the fact is, a lot of language is about stuff that you can see with your eyes and touch with your hand. And that's especially true of the language that we learn.
Well, to take a particular example, there is another difference between those two things in that abdominal uses a very common adjective forming ending, al, whereas chromium uses an uncommon one which generally applies to metals like aluminium and so forth. So it might be that a sufficiently sophisticated child could go and get the chromium plate tray just on the linguistic grounds alone. That said, I'm certainly not...
You're putting me off. I applaud you. That's footwork.
That said, I'm not averse.
For a computer program than for a comic.
Yeah.
I don't know, kids do the darndest things. I mean, there really are some kids who have remarkable linguistic competence. I'm presuming that Paul's kids are in that group. That said, I'm certainly not uninterested in machine vision. There may well be some cases where it were done vastly increase the speed at which you can do this sort of processing if you could look at images, or if you could associate some other source, some other orthogonal data
Your
source.
only understatement of the day.
We should
Yeah, I know that you believe that you need it. A lot of people believe that you need it. I believe that you can get somewhere without it. We'll try this experiment and see whether we fail completely or not.
Sorry if I talked.
Yeah.
Thank you.